All right, so our next customer is an intelligence organization within the US federal government. And just a little bit of background here. So we had an initial meeting with quite a few people from this organization. Following that meeting, we had an individual who was in a C-suite position. He reached out to get a little bit more information about what quantum networking could potentially do for his organization. They wanted a deeper dive in addition to the overview that we'd already given them. After a few more meetings and a few white papers, the customer started to really understand the potential with quantum networking and the importance of getting started immediately. But they weren't quite sure the best way to get additional buy-in within the organization and what initial use case would bring the most value to the organization as a whole. So we requested to speak with various mission owners to get a better idea on what use case we would recommend. And once there was agreement on that use case, we understood and everyone understood that it would provide the most value and impact on the organization. We then went into our requirements gathering and technical discussion. The requirements and challenges that came from that discussion were the following. This agency has employees all over the world. This network needs to be able to support that staff and their mission regardless of their location. And while the customer was very eager to deploy a quantum network now, we had to be realistic about the timelines for a global quantum network. One of the main challenges, especially when working with federal government agencies and not national labs, is the lack of funding for quantum initiatives. We went over some of the funding numbers earlier. However, in the US, a large majority of the funding goes to the national labs and research agencies and not to organizations and agencies like this one. This is primarily because these organizations just didn't know about this technology, and they didn't request that funding during their previous budget cycle, thus the lack of funding for larger scale quantum projects this year. And that is what I'm going to hand off to Danny.
The intelligence organization can start deploying local area quantum networks today to secure communication at individual locations or between nearby locations. Doing so provides great value to the organization and is a vital step toward developing its global QSC solution. For longer distance communication, the intelligence organization can utilize post-quantum cryptography, PQC, a purely classical solution that offers additional, but not provable, security. This is a good short-term solution as the organization's quantum network scales in size. It is important to note that when quantum networks do scale, when its quantum network does scale, PQC and QSC can actually be used together to provide security that has been proven to be at least as strong as each solution individually. To be as effective and efficient as possible, the intelligence organization must appropriately choose where and when it wants to use different scaling technologies, such as quantum repeaters, terrestrial and non-terrestrial optical free space components, etc. This decision-making will be greatly aided by use of a quantum network simulator. By engaging with and educating different members, and specifically the mission owners, throughout the intelligence organization, they will begin to understand the value and applicable use cases quantum networks will provide to support their mission. Mission owners will utilize this information to request additional funding to support the deployment of the quantum network. We give the intelligence organization's plan for implementation as a series of evolving topologies. The locations given in the topologies are not exact, but they do give a sense of how the organization's quantum network will evolve. The organization will first deploy a local area quantum network in the DC area at a single location. This network will provide provably secure communications via QSC between buildings at the location. The organization will deploy a second local area quantum network to secure its location in Hawaii. These two far apart locations will be connected classically and use PQC to offer additional security. The organization will go from solely having individual local area quantum networks to having metro and wide area quantum networks. This will be done through use of terrestrial and non-terrestrial free space components. Here, we see that the Hawaii and DC quantum networks are connected by a satellite and can now use QSC to secure communication between these two locations. The DC quantum network has now scaled from a local area network to a metro area network through use of laser telescopes. An additional local area quantum network has been implemented in Germany and is connected to the DC quantum network classically. This classical connection utilizes PQC. The organization will implement quantum repeaters as they start to become commercially available to help assist in the scaling of its quantum network. Through use of both repeaters and free space components, the network will become global, offering provably secure communication between locations around the world. This is planned to be completed by the end of the decade. While the intelligence organization is most focused on quantum secure communications, it's well aware of and interested in exploring and utilizing the other quantum network use cases. As its quantum network scales, the organization will explore, test, and use applications of distributed quantum computing and sensing for additional offensive and defensive capabilities. Pictured here is an example of what a quantum-enhanced battlefield might look like. The intelligence organization and many other organizations recognize that quantum secure communications is the best, or at the very least a part of the best, long-term security solution. However, PQC can have an important role in the near term for helping to secure communications. There are many important decisions to be made when it comes to how to design and scale your quantum network. Again, knowledge of the field and use of a quantum network simulator will be incredibly important for such decision making.